Welcome to the DIY Honda Garage channel. The DTC P0193 pertains to the fuel rail pressure sensor circuit high voltage, indicating that the voltage signal from the fuel rail pressure sensor is higher than expected. This diagnostic trouble code affects the fuel rail pressure sensor, which is crucial for optimal engine performance. The sensor is located on the fuel rail, usually near the intake manifold, and it measures the pressure of fuel delivered to the engine. If the voltage exceeds 4.89 volts, it suggests a potential fault in the sensor or the related wiring. The Powertrain Control Module, PCM, utilizes this data to adjust fuel injector timing and optimize combustion, making this fault critical to addressing engine performance issues. Proper troubleshooting is vital to ensure effective repairs and the longevity of vehicle performance. The fuel rail pressure sensor plays a crucial role in maintaining appropriate fuel pressure for the engine. It is primarily located on the fuel rail, where it continuously monitors and sends pressure readings to the PCM. If the pressure reading is too high, as indicated by the DTC P0193, it can lead to improper fuel injection calibration and affect engine efficiency. The sensor converts the fuel pressure into an electrical signal, and when this signal exceeds 4.89 volts, it triggers a fault code. Understanding this system helps in diagnosing the underlying issues affecting the sensor and the electrical circuit involved, which can include wiring faults or sensor failures. Furthermore, the role of the PCM is to utilize this information to ensure that the engine runs smoothly, maintaining ideal air-fuel mixture ratios for combustion. Thus, resolving issues related to this DTC is essential for both performance and reliability. Several factors could contribute to the triggering of DTC P0193. A primary suspect is a faulty fuel rail pressure sensor that may have developed internal issues, leading to incorrect voltage outputs. Wiring issues can also play a significant role. Damaged or frayed wires can cause intermittent high voltage readings, affecting overall sensor performance. Poor connections at the sensor or the PCM may disrupt communication, resulting in erroneous signals being sent. Over time, corrosion or dirt can build up at the connection points, thereby increasing resistance and altering voltage levels. Lastly, it is essential to ensure that no other components in the electronic control system are influencing the sensor signal, possibly leading to false readings. Comprehensive diagnostic checks are essential to accurately pinpoint the source of the high voltage issue. Identifying the symptoms associated with DTC P0193 can offer crucial insights for diagnostics. The first notable symptom is the illumination of the check engine light, alerting the driver to a fault within the fuel system. Drivers may also experience engine performance issues, such as stalling, rough idling, or lack of power during acceleration due to improper air-fuel mixture ratios. Poor fuel economy is another common symptom, as the engine may operate inefficiently when fuel pressure reading is inaccurate. Additionally, when the vehicle experiences difficulty starting or exhibits erratic engine behavior, those could also be linked to the high voltage reading from the fuel rail pressure sensor. Therefore, monitoring these symptoms ensures that appropriate troubleshooting measures can be taken timely. The first step in troubleshooting DTC P0193 involves verification of the problem. Start by switching the vehicle to the on mode, allowing the vehicle systems to initialize with a wait time of about 2 seconds. It's critical to use the Honda Diagnostic System, HDS, to check the fuel pressure sensor voltage values using the parameters provided. Specifically, you should look for whether the fuel pressure converted from the sensor is 4.89 volts or more. Upon verifying if the conditions match the specified threshold, if they do, the next steps in the troubleshooting process can be pursued. However, If the voltage does not meet the threshold, the situation indicates an intermittent failure, suggesting the system may be operational at that moment. In that case, it's advisable to inspect for any poor connections or loose terminals at both the fuel rail pressure sensor as well as at the PCM. Recording the onboard snapshot of the DTC aids in reproducing the failure under similar conditions for further investigation. For the second troubleshooting step, begin by placing the vehicle in the off-lock mode. This action ensures that no power is running through the system, allowing for safe disconnection of electrical connectors. Disconnect the fuel rail pressure sensor 3P connector, which is responsible for relaying pressure readings to the PCM. To simulate a properly functioning sensor, connect terminals A, number 1, and B, number 2, with a jumper wire, effectively creating a direct signal path. This step is crucial in determining whether the sensor itself is malfunctions by replacing it with a bypassed signal. Following this, return the vehicle to the on mode and use the HDS to check the fuel pressure sensor voltage once more, ensuring it reaches at least 4.89 volts. If the reading meets the specified threshold, it indicates that the sensor is likely faulty and should be replaced. Conversely, if the issue persists, further examination of associated components is warranted. In the third troubleshooting step, return the vehicle to the off-lock mode again to ensure safety while working on the electrical system. Remove the jumper wire that was previously connected between the fuel rail pressure sensor terminals to return to normal diagnostic conditions. Then, turn the vehicle back to the on mode without any connectors attached to the sensor for accurate measurement. Utilize a multimeter to measure the voltage between designated test points. Test point 1, the second terminal of the fuel rail pressure sensor 3P connector, and test point 2, the third terminal of the same connector. It is critical to assess whether the voltage falls around 5.0 volts, as this indicates the integrity of the wiring harness and signals from the PCM. If the voltage is detected in the correct range, the wiring and PCM signal lines are functioning properly, allowing the technician to proceed with further investigations. However, should the voltage level be outside the acceptable range, it necessitates a deeper dive into wiring or connectivity issues. At this stage, the next step involves performing an open wire check on the PF line. Start by switching the vehicle to the off-lock mode to safely work with electrical circuits. Using the HDS, jump the SCS, service check connector line, and allow for a waiting period of over 1 minute to ensure the system is reset for testing. Disconnect the PCM connector E, 80P, which connects the PCM to the vehicle's sensor system, ensuring it's isolated from the diagnostic process. Afterward, conduct a continuity test between test point 1, female terminal number 1 at the fuel rail pressure sensor connector, and test point 2, pin number 72 at the PCM connector. If continuity is present, this indicates that the PF wire is functional and unharmed. In that case, further assessment of authorized service information relating to the DTCs or symptoms could be evaluated. If continuity is absent, an open circuit exists in the PF wire between the PCM and the fuel rail pressure sensor, necessitating repairs to resolve the issue. The final troubleshooting step focuses on verifying the SG1 line for any faults. Initiate by again switching the vehicle to the off-lock mode to ensure safe operation of electrical components. Similar to the previous step, bridge the SCS line using the HDS and allow for a 1-minute interval for systems to stabilize. Disconnect the PCM connector E, 80P, to isolate the wiring for accurate assessment. Following this, assess continuity between test point 1 the second terminal of the fuel rail pressure sensor connector, and test point 2, pin number 71 at the PCM connector. If continuity exists, it confirms that the SG1 wire is intact and functioning correctly, allowing you to investigate further based on authorized service information related to the DTCs or symptoms. However, if there is no continuity detected, repairs will be necessary to fix an open circuit in the SG1 wire running between the PCM and the fuel rail pressure sensor, as this fault can lead to misleading sensor readings and subsequent performance issues. Once repairs related to the DTC P0193 code are completed, it is essential to undertake a final verification process. Start by ensuring that the DTC has been effectively cleared from the PCM using the HDS. Following this, conduct a test drive of the vehicle under various conditions to assess if the repairs have resolved the initial issues. Pay particular attention to monitoring the dashboard for any indications of the check engine light re-illuminating. Confirm that the previously observed symptoms, such as poor engine performance or responsiveness, are eliminated. An effective final verification process guarantees that all repairs adequately address the persistent issues and establishes that the vehicle is once more operating at optimal levels. If any symptoms persist or the DTC reappears, it necessitates further investigation to locate any residual problems not resolved in prior steps. Preventive maintenance actions can significantly mitigate the likelihood of encountering issues that trigger DTC P0193 in the future. Regular inspections of the fuel rail pressure sensor should be a part of routine maintenance, checking for signs of wear, corrosion, or damage that may affect performance. Consistent checks of wiring and connections associated with the fuel rail pressure sensor are essential in avoiding connectivity issues that can lead to high voltage readings. Ensuring cleanliness within the fuel system is also crucial. Using high-quality fuel filters and additives can prevent debris buildup that could hinder fuel flow and sensor accuracy. By implementing these preventive measures, owners can prolong the lifespan of the fuel system components and maintain overall vehicle performance, ultimately saving on repair costs in the long term. A proactive approach contributes to a reliable experience behind the wheel, enhancing confidence in your Honda Accord's functionality. In summary, understanding the impact and implications of DTC P0193 is crucial for maintaining your Honda Accord's performance and reliability. Following the correct troubleshooting steps not only aids in making informed repairs, but ensures that every potential failure point is addressed comprehensively. From verifying sensor functionality to conducting open wire checks, each step plays a significant role in diagnosing high-voltage issues within the fuel rail sensor circuit. Additionally, regular preventive maintenance practices will greatly reduce the risk of recurrence of such problems, ensuring the vehicle operates smoothly and efficiently. Ultimately, being proactive and informed leads to enhanced vehicle longevity and performance. This approach cultivates a driving experience marked by minimal interruptions and maximized enjoyment. Please like and subscribe to the channel. See you next time.